Hello again, and we are going to continue with our ISTEP review. The category is data analysis, statistics, and probability. So these are again some problems that I have pulled from the Indiana Department of Education website, and I'm just going to work them out and show you how to do these. And these are problems that I think will be similar to some of the things that you might see on the ISTEP. So in this first problem, number 6, data for 10 students' math and science scores are provided in the table. So here's our table. Construct a scatter plot for this data and describe the association between the math and science scores. So using this data, first of all, I'm going to graph it. So let's zoom in a little bit so we can see our graph a little bit better. And I'm going to try to be as precise as possible. So the math scores are on the x-axis, the science scores are on the y-axis. So 85, 83 would, well, before I begin, I should probably look at what my intervals are. So if this is 20, that means that this is 10. So I am basically, every line is increasing by 10. So then 85 would be halfway between 80 and 90. And then I would go up to 83, which again, this is 80, this is 90, so 83 would be about right there. So let's see, about 85, 83 would be about right there. So that's about the best I can make it. So it looks like it's a little bit above the 80 on the science side, and then about halfway between 80 and 90 for your science. The next one is 50, 70. So this is the 50 line, and then go up to 70, which is going to put us right here. The next one, 64, 68. So 64, again, this is 70. Sometimes it helps if you want to put those numbers in just to kind of remind you that these are going up by tens, and that's 50, and that's 30. Same thing here, your y-axis, these are basically going up by tens also. So, all right, so I graphed the first 2 points. My third point, C, is 64, 68. So 64 would be about a little bit closer to the 60, but almost halfway between 60 and 70, and then up to 68, which is going to be almost 70. So approximately right there. All right, next one, 42, 40. So 42 is right here, and then I go up 40, which is right there, so it should look like that. 56 and 60, so 56 between 50 and 60, but maybe a little bit closer to the 60, just barely. And then your science score was 60, so that is about right there. 93, 96, so here's my 90, so 93 would be about right here. 96 would be up here. 34, 33, so 34, and then 33, about right there. 24, 27 would be approximately right there. 63, 63. So that one's really close to this other one that we had, that was 64, 68. And then 72, 74. Okay, so we did the first thing, we constructed a scatter plot. So this is our scatter plot, it just is the points from the data. And they want us now to describe the association between the math and the science scores. So if you look at the math scores, as they are increasing, the science scores look like they are increasing also. So there's a positive correlation between the math and science scores. So the description, describe the association is a little bit vague, so I'd rather give a little bit more information than not enough. So I would say no, I don't want to start with the. As the math scores increase, let me move that over so you can see it. As the math scores increase, so do the science scores. So there is a positive correlation between the math and science scores. So I would probably put all of that. I'd rather have, like I said, a little bit over-explained than not explained enough. All right, so that's all we had to do for that problem. Moving on to the next page, number 7. Again, we have some data. We got a table. They're asking us to construct a scatter plot for the data such that the distance traveled is the dependent variable. So if you're not familiar with dependent and independent variables, the dependent variable is the one that's on the vertical axis, or we call the y-axis. So the dependent variable is on the vertical or the y-axis. And the independent variable is the one that's on the x-axis. So they're telling us that the gasoline used is the independent variable. So this is gasoline used. And that again is independent. So independent is basically your horizontal or x-axis. So just little notes there. Now let's graph the data. So if I've used a so this is Ellen. So Ellen's fuel tank, it holds 13.5 gallons. Before the trip, she filled it up completely with gasoline. And so the table shows us the gallons of gasoline used versus the miles traveled. So if we graph these points, 1.8 and 45, again, let's look at our intervals here. The gallons look like every line is going up by 1. So this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and that last line would be 14. And then if you look at your your miles, your dependent variable, or your y-axis, this is 50, so this would be 25, 75, 125, 175, and 225. So having those extra numbers in there might help a little bit with the graphing. 1.8 is going to be between 1 and 2, but closer to the 2. And then you're going up 45, which is a little bit below the 50 mark. So there's our first point. And then 2.4, 60. 2.4 is between 2 and 3. And then up 60. So about right there. And again, we're not going to be able to make these perfect, but you just want to put it as close to those values as possible. 3.8 and then 100. So 3.8 would be close to 4, but not quite, up to 100, which is right there. And then 5.5, 150. 5.5 would be right here, and then up to 150 would be right, put us there. 7.3, 200. 7.3, and then going up 200. Puts us about right there. Good. And then 8.2, 225. 8.2 is just barely past the 8, and that 225 would be up there. All right, so we graphed the data, and they want us to, again, describe the relationship between the data, or the variables. So our variables are the gasoline used and miles traveled. So the more gasoline that is used, or more gallons of gasoline used, comma, the more miles traveled. So that's one way of saying it. You could have also said, as the gallons of gasoline used increases, so do the miles traveled. You could also say that there is a positive correlation between the gallons used and the miles traveled. So something to that effect would be sufficient. So that's describing the relationship between the variables. In the next part, they're asking us to sketch a line to fit the data. So without a graphing calculator, you're not going to be able to do the best fit line, but you're going to want to get a ruler. So give me a minute to get a ruler. Okay, so I like to use these clear rulers because when you draw a line of fit or a line of best fit, you want to include the most amount of data that you possibly can. If you can't include all of the data, then you want to have an equal amount of points above and below the data. So this is about as close as I'm going to get there. So again, everybody might draw the line just a little bit differently, so your line might be a little bit off from other people's, but it should be pretty close to that. All right, so there's my line of fit or line of best fit. The next thing they're asking us to do is write a linear equation to model the data. So we want to write an equation to represent that line. Well, in order to write an equation that represents that line, you need 2 points that are right on the line. So they could be points that are on the data, or they could be points that are not part of the data. So if I'm looking through here, I'm looking for a really maybe good point that's easy to identify. So this one here was a pretty good point. That's one of my data points. That was the point 1.845. So I can use that for one of my points. And let's see, I'll again use this point here. But you don't have to use data points. You could use maybe this point here or this point here. It just has to be 2 points that are on the line. But since I do have 2 points that are pretty much on the line, on my line, I'm going to go ahead and use those 2 points. And the first thing I'm going to do is find the slope between my 2 points using my slope formula. So m equals my y2 minus y1 over x2 minus x1. So I'm going to call this my x1 and my y1. And this is going to be my x2 and y2. So when I plug my values in, I'm going to take the 150 minus 45 at the top, and then 5.5 minus 1.8 at the bottom. So the 150 minus the 45 is going to be 105, and then the 5.5 minus 1.8 is 3.7. So then we're going to go ahead and divide that. It's not going to be a nice whole number, but that's okay. We'll just round it to, it doesn't really tell us what to round it to, so we're going to round to the tenths. So as I divide, when I divide here, if I round to my tenths, it's going to be 28.4. All right, so that is, I'm going to bring down here. So my slope is 28.4. The y-intercept should be pretty close to 0. But we can't really assume that it's 0. I should probably plug it into point slope form. So let's do that. Y minus y1 equals m parentheses x minus x1. So again, I'm going to use my x1 and y1 that I have from these points here. I'm going to plug them in along with my slope, and then I'm going to solve for y to see what the y-intercept is. So y minus my y1 was 45, my slope 28.4, x minus my x1, which is 1.8. Then you're going to distribute the 28.4, so y minus 45 equals 28.4x, and then when I take that 1.8 times the 28.4, I'm going to get 51.12, and it's going to be a minus. And then I would add 45 to both sides of the equation, which would then give me y equals 28.4x minus 6.12, or 6.1. Now realistically, it's telling us that at 0, so at 0, if we plugged in 0 for x, which is our gallons, so this is saying at 0 gallons we would go negative 6.1 miles, which probably is not very realistic. So I'm not sure whether they would accept y equals 28.4x and then just leave it like that, because if you put a plus 0, your y-intercept should be 0, because if you think about it, if you have 0 gallons of gasoline, then you should be going 0 miles. So that would make logical sense. However, if we are using those 2 points, then and we plug it into point slope form, algebraically we get a y-intercept of negative 6.1. So again, whether or not they would accept, the ISTEP would accept this or this, I'm not real sure. I guess it depends on whether you show all the work and whether they are clear about the instructions. All right, so the next thing that I would ask is, they're asking is, what does the slope of the y-intercept represent in terms of the context? So the more I think about it, I'm thinking that 0 would probably be a better y-intercept, again, because in terms of the context, so in terms of what we're doing, you're not going to be able to have a negative y-intercept. So I'm going to just scrap my algebraic equation and say that my equation is 28.4x. I do not need to put the plus 0 after it. But as far as my slope and y-intercept, what does it represent? So the 28.4 represents, so I would say something like my slope, comma, 28.4 represents the number of, so we look at what is the rise over the run. So slope is rise over run. So what's going up? The miles, and as we go over the gallons. So you're going up basically 28.4 miles per gallon is what this is, what the slope is saying. So it represents an increase of 28.4 miles for each gallon used, or something to that effect. So that's what I would say. It represents an increase of 28.4 miles, so the miles are increasing for each gallon that's being used. All right, the y-intercept, so again, if I use 0 for my y-intercept, which logically makes sense, that would represent the when 0 gallons of gas are used, we have traveled 0 miles, or Ellen has traveled 0 miles. So again, I'm saying that my y-intercept is the 0.00, because if you're going if you're using 0 gallons, then you should be going 0 miles. Logically, that makes sense. Okay, use your equation to predict the number of miles that Ellen could travel before her fuel tank is empty. So if, in order for her fuel tank to be empty, that means that she has to have used 13.5 gallons. And they gave us that information at the very beginning when they said that her tank has a capacity of 13.5 gallons and that she completely filled the vehicle with gasoline. So so the 13.5 is the number of gallons. So we're going to substitute 13.5 for x, because our x is the number of gallons, our y is the number of miles. So in my equation, y equals 28.4x, again, I'm going to put 13.5 in for x because that's representing my gallons, and then multiply 28.4 by 13.5. So y is going to equal 383.4. So basically I'm predicting that Ellen can travel approximately, or you can say about 383.4 miles before her fuel tank is empty. So there you have it. And that's how I would find it. And again, the answers might be a little bit different based on which points you use to write your equation. Okay, the next problem here says a survey of high school students was conducted to measure teenage use of illegal drugs. How might this sample be biased? So as I was reading this, I realized they have the answer right here. So basically it would be biased because it would not include all the teenagers. So they're saying, you know, this is measuring teenage use. So teenage use means all teenagers. So this, if you're only surveying high school students, then you're not including other teenagers that may be like 19-year-olds that have already graduated or 18-year-olds that have already graduated. You've also got 13-year-olds sometimes in middle school. So you're not including all the different teenagers, that teenage groups, that high school does not represent all the teenage groups, is basically the point. So maybe we should put that in here. High schoolers alone do not include, it's supposed to be a C, all teenagers. So that's about it. All right, moving on. So in this problem, Lisa lights a candle and records its height in inches after every hour. Some of her data recorded as time and then height are listed here. So the x coordinates are representing the time and the y coordinates are representing the height. So again, we would graph the data. So 0, 20, that's going to be our y-intercept, which basically probably tells us at zero, this is at 0 time, the height of the candle is 20 inches, so it was probably a 20-inch candle. After one, and these are hours? Yes, hours. So after 1 hour, yeah, every hour. So after 1 hour, now we have 18.3 inches. After 2 hours, it's 16.5 inches. After 3 hours, it's 14.7. After 4 hours, it's 13.4. After 5 hours, it's 11.4. Again, you're going to try to just be as exact as possible, and if you notice, these intervals are going by 2s where these are going by 1s. So you want to keep that in mind when you're graphing your points. All right, so they don't have a point for 6, so then jump to 7. So 7 and then 8.1, 9 and 4.7, and then 10, 3. All right, so it looks pretty close to a nice straight line. So again, they're asking us to describe the relationship between the variables. So as time is increasing, the height of the candle is decreasing. So we could include the candle being lit, but I'm just going to keep it simple. So as the time increases, the height of the candle decreases. And you could also say that there is a negative correlation between the time and the height of the candle, between the number of hours and the height of the candle. All right, so there again, I'd rather be a little bit more, include a little bit more description than not enough. So again, as the time increases, the height of the candle decreases. There is a negative correlation between the number of hours, which is basically our time, and the height of the candle. So a couple different ways. Now they want us to express the candle's height as a function of time. So h is your the name of the function, t is your time that you're associating with the height. So basically this is going to again be writing an equation of a line. So if we look at our line here, I'm going to use my ruler again to try to line up all of our points, and it looks like they pretty much all line up pretty well on there. A couple of them are off a little bit, and again, that might be human error. So again, you want to use points that are exactly on the line. So see this point right here, this was not one of our data points, but that is, the line is going right through that point, so I'm going to use it. So that's the point 8, 6. And then your y-intercept is always a very good point to use. That's your starting point, so 0, 20. So then if I find my slope again, m equals y2 minus y1 over x2 minus x1. And I'm going to call, I'm going to use a different color. So I'm going to make the 0, 20 my x1 and my y1. And the 8, 6 is going to be my x2 and my y2. So I should be getting a negative slope here because it has a negative correlation. Oops, I'm supposed to put a 2 there. All right, so my y2 is 6 minus my y1, which is 20, over my x2, which is 8, minus my x1, which is 0. So that's going to give me a slope of negative 14 over 8, which if I reduce that or even divide it, let's see, what does it divide evenly? Yeah, pretty nicely, negative 1.75. So as far as describing this, that is something that they asked down here. So state the meaning of the slope and the intercepts in points in terms of the burning candle. So the slope is basically representing that as time is increasing, the height of the candle, or you could say it the other way around, the height of the candle is decreasing as time is, or decreasing 1.75 inches every hour. So that's exactly what the slope represents. So the height of the candle is decreasing, and here's where I'm going to put my slope in, 1.75. Notice I don't put a negative here. The decreasing is taking care of the negative. 1.75 inches every hour. And notice we also included our units of measure in our description. That's always something that you want to do. So the height of the candle is decreasing 1.75 inches every hour. All right, so the y-intercept, we do have that. On your graph, the y-intercept is at 0, 20. So basically the y-intercept would represent the height of the candle before it was lit, or the starting height of the candle. So there's a couple ways you can say it. So the height of the candle was 20 inches before it was lit, or the starting height of the candle was 20 inches. Again, that's just something that different way of saying it. x-intercept. So in order to find the x-intercept, we need to again go back to maybe writing the equation. So our line doesn't quite go to the x-axis, so we're going to have to continue writing our equation here. So I'm going to use point slope form, kind of like I did in the last example. Y minus y1 equals m parentheses x minus x1, and I'm going to substitute my y1, which was 20, my slope, which is negative 1.75, and my x1, which was 0. And then if I distribute, I would just get negative 1.75x. Oh, this was really silly. I didn't have to do this. This is more work than what I needed, because I already know my slope and my y-intercept. I'm not thinking. All right, so y equals negative 1.75x plus 20, which we could have gotten right away at the beginning if we just put it into slope-intercept form. We found our slope, we already knew our y-intercept, so we could have just plugged it into the slope-intercept form. All right, but how does that help us find our x-intercept? Well, an x-intercept always has a y-coordinate of 0. So we need to figure out what the x-coordinate is. So we can take our equation and put 0 in for y and then solve for x. So if I put 0 in for y, then subtract my 20, and I'm running out of room, and so let's write it over here. Negative 20 equals negative 1.75x, and then I would divide by the negative 1.75, so that we'll get a positive value. So we should get a positive value. It looks like it's going to cross the x-axis on the positive side. So negative divided by negative is positive, but then when we take our 20 divided by 1.75, we get, it's a decimal that doesn't repeat, so 11.4. So x is approximately 11.4. All right, so that's our x-intercept. So it's going to be crossing, if we continued this graph, it would be crossing at approximately 11.4, and that's our time in hours. So basically what this is saying is that at 11.4 hours, the height of our candle is going to be at 0. So after 11.4 hours, or approximately, or about 11.4 hours, again, that's not going to be as exact as, if we used a graphing calculator to these points, plug these points in. So after 11.4 hours, the candle is 0 inches. So, or basically it would burn all the way down to the end. All right, so that is the end of this lesson. We've got linear equations coming up and inequalities and functions, which a lot of this that we did is going to be similar to, it's going to be the same kind of stuff that's in the next section. But we'll do that one another day.